Data visualization is more than just charts and graphs. It is about finding creative ways to see your data differently. In today's video, I will show you how to create a word cloud that highlights the most important parts of your text data, and you can do it just in a couple of steps. If you're new to this channel, I'm Karina. I have transformed my career from finance to data, and I'll help others to do the same one step at a time. So what is word cloud? Word cloud is a text representation of data where the size of each word indicates its frequency or importance within a given body of text. Words that appear more frequently or considered more significant are displayed in larger, bolder font, while less important words are shown in smaller fonts. Word cloud is a great way to visualize data such as social media comments, customer feedback, or call center notes. I've created word cloud for different dashboards, and one of them was for call center data. When you look at the word cloud, there would be several words or word combinations that stand out. And in that example, the word password suddenly start appearing. So when you look at the last 24-48 hours, you see that a lot of the people who were calling call center were talking about password. And when we dig deeper in the data, we notice that a lot of people tried to reset password or had issues with their password. So there were some changes made to the product that caused that. And probably you can wait for some weekly meeting where head of call center comes and reports that they have issue with some password resets, or you can see this data quite quickly on your dashboard. That's why word cloud is a great way to work with text data. To create our word cloud, we need text data, and I found one at kaggle.com. That's my favorite resource, link in the description to this data set. So the very first step, you need to install a library called word cloud. So pip install word cloud, you need to run it and install it into your environment. Now let's import libraries that we will be using for this project. So we will import pandas SPD because I need to read the file. We import it is a regular expression, we will talk about it later. We import NLTK, and then from NLTK tokenize we import word tokenizer. From NLTK corpus we import wordnet and stop words. From NLTK stem we import wordnet lemmatizer. From word cloud we import word cloud to create our word cloud, and import matplotlib, pyplot, splt, and there would be some other libraries we will import as we go. The first step, we need to read our file. As always, we use pandas to do that. df equals pd.read_csv brackets. In the brackets in quotes you indicate the path to your file, and we want to see 5 top rows of our data. That's why we say df.head brackets. Let's run it. That's how our data looks like. Obviously you can do some data analysis with this data, but we will not focus on it today. I will just use this data to create a word cloud, and we will create a word cloud from employee notes. One of the first steps we will do, we will remove special characters because they don't bring any extra value for our data, and it's usually done as the very first step. So you remove question marks, dots, commas, etc. We will create a function called remove special characters. To create a function in Python, we always start with def, then the name of our function, which will be remove special characters, bracket text, colon, and then return, because you need to return the result from your function, re or regular expressions, dot sub, brackets, and then in brackets we indicate what we want to do. So we want to say remove all the characters except for letters. In Excel we have a find replace, where we find something and replace it with something else, for example with a space. That's what we will do with this function. So we say sub or substitute, find everything that is not a letter and replace it with nothing. And where would we find it? We find it in our text. If you're interested, I can make a video about regular expression because it is like a separate language, and you know, with its own characters and funny things. For example, this little head is caret sign, and it means except for, so everything except for. So we will create a new column called cleaned node. So we say df or name of our data frame square brackets cleaned node. That will allow us to create a new column. So all the results after removing special characters will be in a new column. Equals name of the column where we apply our function to. We apply it to employee node, and dot apply bracket in the brackets name of our function. Let's run it. And I will keep running df head so we can see all the transformation that is happening to our column. So now we have a new column, as you can see here. So I keep my employee node untouched, but on the side we have a new column. And you can see that, for example, we don't have any dots anymore. But you can see some of our words start with capital letter because, of course, we had several sentences with a dot. So some words start with a capital letter. Because of that, we need to convert all our text to lowercase or uppercase. It's up to you. I usually convert to lowercase, but we need to make all the text consistent. Otherwise, customer with capital letter and customer with lowercase will be considered as two different words. So the next step, we convert everything to lowercase. df clean node equals df clean node dot apply brackets in brackets lambda x colon x dot lower brackets. Let's apply it and let's rerun our head. And now you can see that all the words are now lowercase. The next step is tokenization. Tokenization is the process of breaking down the text into smaller units, typically words or phrases called tokens. So for example, if you have a sentence, I love programming, after tokenization it becomes 3 different words, I, love and programming. We already spoke about word tokenization in another video about Hugging Face. Remember, we imported word tokenization from NLTK. NLTK is Natural Language Toolkit library, which is a very popular Python library used for working with human language data. NLTK library already has necessary tools for you, for example, tokenization, stemming, lemmatization, as well as some tools to visualize your data as word frequency distribution, and word clouds. To do our tokenization, we need to download punked or pre-trained model from NLTK. So we say nltk.download brackets punked, and we will create a brand new column tokenize node instead of making changes to this clean node. But you can make all the changes in the same column. I just want to create several columns to show you how things progress. So we say df square brackets tokenize node to create a new column equals df square brackets clean node dot apply brackets word tokenize. Let's run it and let's again run df.head to see the changes. Okay, so now we have a new column tokenize node, and for example we had this one sentence where a customer inquired about new package, and now this sentence was split into different words. The next step, we will do lemmatization. Lemmatization is a process of reducing a word to its base or root form known as lemma. So for example, words running, run and runs all have the same lemma run. To do lemmatization, we need to download WordNet and OMW 1.4, and then we say lemmatizer equals WordNet lemmatizer brackets. And again, I will create a brand new column called lemmatized node. So df square brackets lemmatized node equals df square brackets tokenized node, because we will apply it to this column, dot apply brackets lambda x colon in square brackets lemmatizer dot lemmatize word for word in x. So with this lambda function, we say take each word and lemmatize each of those words in this column. Let's run it and let's again rerun df head. And if you look at this lemmatized node, for example, here you can see that packages was changed to package, offers to offer, claims to claim, etc. The next thing we will do, we will remove stop words. Stop words are the words that don't bring any value for analysis. So those words are usually article, pronouns, conjunctions, prepositions, or auxiliary verbs. If you don't remove them from our text, on a word cloud they will pop up as the most frequent words, but they don't carry any meaningful information. That's why we have to remove them. NLTK already has a library called stop words that has all these prepositions and articles in it, so we can use it to remove stop words from our text. To do that, we need to download stop words from NLTK. We say nltk.download brackets stop words, and then we say stop words equals set brackets stop words dot words English. And now let's apply it to our lemmatized node. We say df square brackets lemmatized node equal df square brackets lemmatized node dot apply brackets lambda x colon square brackets word for word in x if word not in stop words. You can see we use dot apply brackets function, and it is used to apply a function to each element in our column that we indicated. And in square brackets you see this word for word. It is a list comprehension, and this list comprehension is used to iterate over each word and apply it to every single word in a list X. Okay, let's run it and let's again run df.head to see any changes. You can see that some words disappeared. For example, and, on, at, doesn't exist anymore in our lemmatized node column. Just a quick reminder that if you join my newsletter, you will have an access to different free resources, including resume template, different books on statistics, Python and R, and I trying to keep it updated and add more and more freebies. So you can join my newsletter, link in the description. Okay, now it's time to create our word cloud. We split our words into separate tokens so we can apply all the stemming, remove stop words, etc. But now we need to combine all our text together so we can create a word cloud. So we need to join back all the words. So we create a new variable called all words equal, and then quotes with empty space because we want to have empty space between our words, dot join, brackets in brackets, square brackets, and again quotes with a space, dot join words for words in df lemmatized node. The square brackets part takes each list of lemmatized words in our lemmatized node column and joins the words within each list into a single string. So for example, if we had inquired new TV package offer, it will become one sentence. And then we do an outer join with this quote dot join, and what happens, it takes all the strings created in the previous step and joins them into one large string with a space separating each of those strings. So this will result in a single string that contains all the words from all the lists in the lemmatized node column and combining all the text in that column into one long piece of text that we can use to create our word cloud. And now let's create a word cloud. So word cloud equals word cloud brackets, width will be 800, height 400. Again, you can play around with parameters to adjust it to your liking. Background color white, by default it is black, it's very hard to read, so I do by default white. Dot generate brackets all words. And we need to display our word cloud using matplotlib, exactly the same as we do with other graphs. If you've seen my other videos, you probably already know how to create graphs with matplotlib. So we say plt.figure brackets figure size 10 by 5, plt.show word cloud, comma interpolation by linear, plt axis off, so no axis for the word cloud, and plt.show to display our word cloud. Let's run it. And that's how our word cloud looks like. So for example, we have behavior analysis, analysis personalized, pattern analysis, these things that stand out. By default, you can see that our word cloud in this rectangular shape, or you can make a square shape. But what I like, you can upload the image you want, whatever it can be. It can be Apple logo, it can be Mickey Mouse, it can be anything you want, and you can put your word cloud in a shape of that image. So let's do it. To do that, we will work with PIL library. It is image library. So from PIL import image and then import numpy as np. So we need to import other two things. And now we need to upload our image. So mask underscore image underscore path equals, and I indicate the path to my image. I downloaded lightbulb from the internet and I will be using that as my image. We will see it in a second. And so background image equals numpy.array image.open, and then in brackets mask image path, and plt.imshow brackets background image to display that image. So let's run it. This is the image I downloaded, and we will create a word cloud in a shape of this light bulb. We say word cloud 2 equals word cloud brackets background color white mask background image, or this image. Then width height generate all words. So similar to what we've done to generate this word cloud, but this time we use background image as our mask. And then plt.image show word cloud to interpolation by linear, plt axis off, so we remove this axis, and plt.show to display. Let's run it, and now our word cloud is in a shape of this light bulb. You can play around with different parameters. For example, we will also add contour color as white or color map copper. Let's run it. And this time our words not as colorful as they were here, but now, for example, we have black and brown, and we can see that behavior analysis, analysis personalized stand out more. I've seen another option is a color map called a pad. So let's change it, and this time we have a very colorful image. Another option, color map bone, and we're changing our contouring color. So let's run it, and you see it's more black and gray and maybe more visible. Of course, it all depends on what you're trying to achieve and what is more convenient for stakeholders who will be using this word cloud. But as for fun, you can change this rectangular or square format of your word cloud into something more exciting. I've seen how people do analysis for Apple, Meta, and they put all the word cloud in a logo of Meta and the words in a logo of Apple. You can do that. That's it for word cloud. I hope you enjoyed this video. Let me know in the comments if you've done word clouds before, if you're planning to add them after watching this video. I hope you enjoyed this. If you made so far, please click like and subscribe. It means a lot to me, and I hope to see you next time.